Let's talk about the Mcclaurine series. The Mcclaurine series is just the Taylor series centered at x equals 0. And all of these are derived by the formula of the Taylor series. And you get these very particular identities and expansions. So for example, if we take e to the x, we have 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial, and so on and so on. So all of these expansions are derived from the Taylor series, and they are very important. The IB expects you to know all of them, and all of the questions involve you to use them. So that'll be the first step. So let's take a look at this example. Find the Mcclaurine polynomial of degree 4 for e to the negative x squared. Now, the very first thing you need to identify is what is the base identity? So what is the base function that we are going to manipulate? Well, in this case, if we look here, it is going to be e to the x, which I've brought the identity right here. And now we know that e to the x is equal to 1 plus x over 1 factorial plus x squared over 2 factorial plus dot dot dot. Now, all we have to do is replace this to this, and that will help you expand it out. So you put in the negative x squared, and now you just replace all x's with negative x squared. So that will look like negative x squared over 1 factorial plus negative x squared squared over 2 factorial. And then you go one more, it would be negative x squared to the 3 over 3 factorial, and so on and so on. It is also important to recognize that right now we're only interested in degree of 4. So that means we are only interested up to x to the 4. Anything above that we don't care about, and we're not going to include in our answer. So we get 1 minus x squared plus x to the 4 over 2 minus x to the 6 over 6 plus dot dot dot. And as again, we do not want this term because it is x to the 6. We don't care about that. So therefore, the answer is 1 minus x squared plus x to the 4 over 2. And that is our 4th degree Mcclaurine polynomial. So let's take a look at a slightly harder problem. Find the Mcclaurine polynomial of degree 3 for f of x equals e to the x sine x. So what we need to do here is multiply these two different identities by their corresponding Mcclaurine series. So it'll be f of x equals e to the x times sine x. And let's represent this as 1 plus x squared over 2 plus dot 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 times x minus x to the 3 over 6 plus dot dot dot. Now, let's go ahead and expand this. I'm going to expand it like this, and then like this, and then like this. So let's see this. We get x minus x cubed over 6, like that. And then we get plus x squared minus x to the 4 over 6. And then we get plus x to the 3rd over 2 minus x to the 5 over 12. Now, like I said in the last video, if the question asks for up to a specific degree, in this case is degree 3, we shouldn't care about any other terms that exceed this. So that means we can confidently not include x to the 4 or this x to the 5 in our answer. And also keep in mind that if we continued to expand the next terms on and on, because the series essentially never ends, we would continue to get terms that exceed the degree of 3. So we also don't have to consider that in. And now we are very happy because these terms are the terms that are going to be the only terms that are less or equal to 3. So let's finish this off. It becomes x plus x squared minus x3 over 6 plus x to 3 over 2. And this becomes x plus x squared plus 1 over 3 x cubed. So that is going to be our Maclaurin polynomial of e to the x times sine x up to degree 3.